In this exercise, we're going to be discussing the constraint tool. The constraint tool is what allows us to apply the constraints to remove the degrees of freedom to lock down the parts. So let's take a look. To start with, top to bottom, left to right here, as always, we have the mate constraint, and it has two different solutions, which I really don't like the way they name this because this is mate and this is mate, or you can go mate flush. So mate or mate flush. So usually if I'm telling you to put a mate constraint on something like this will be flush, like this will be mate. If I hit escape here, say I constrain this and this object, as soon as I hit the constraint tool, they snap together. However, if I hit constraint and I turn this on, predict offset and orientation, what that does is that leaves the part where it was. It says, okay, for some reason you want that to be 134.911 millimeters off. Chances are you don't want it to be that odd number, but what I have had happen is if I let it snap together, it could accidentally invert or something. So maybe I do want it to be negative 135 millimeters apart. So if I turn that on, it'll leave them separated and allow me to come in here and tweak it. If I turn this off, it'll automatically snap to itself. Now, one of the things is if you do have this turned on for some reason, don't leave it on because you'll forget about it and then you'll go to put two things together and they won't move and you can't figure out why. So if you need it to be a certain distance apart, toggle that on. If not, toggle it off. Don't need it, don't use it. It is a very helpful tool, but sometimes it can get in your way. The other options with mate, I always tell people to think of mate as gravity. Mate is a really good example of gravity. Take a book or a mouse and you lay it on your desk. You mate those two surfaces together because of gravity. Just because they're mated together doesn't mean they can't move. So we hit OK or apply here. We turn on degrees of freedom. So now you can see they still have X and Y, they just don't have Z. And they can actually rotate about Z, they just can't rotate around the X and Y. So we've removed some degrees of freedom, but we've not removed them all. So let's undo that for a second, because I don't want to lock those together. Not yet anyways. If I come back up here to the constraint tool, the other option with mate is cylinders. I can mate the center line of that cylinder to the center line of that washer, and it'll lock them together. If I hit apply, I'll show you the insert constraint, which works very similarly. If I select the outside face of this and the inside face of my little bushing here, they'll go together. And I'm going to hit OK so I can move it out of my way here. And the difference is these two are locked together and can't move away from each other. If I go back over here to view and I turn on degrees of freedom, I can see that basically they're locked together, but they can rotate. That's all they can do. Whereas if I use the mate to the axis, this can actually slide up and down and spin. So it depends. Do you need to lock it down to the exact spot or let it move up and down? If I were to come in here and do the insert constraint on this, it would lock it to this spot. If I want to remove that, so I can show you what the insert constraint would look like. Say insert, that ring to that ring. I can still put like an offset in it, but once I do that, that part isn't going to move. It can still rotate like this one, but can't move up and down anymore. The other option you have with the insert constraint, if I select this again, you'll notice I have an arrow here as I go to select it. It'll flip upside down. And basically what that's saying is do you want the two faces to be perpendicular or parallel to each other? Just like mate and flush. So if you ever accidentally grab the wrong side of a bolt or something like that and you see it do this, you can just toggle this around and it'll give you the proper insert. I can do it once more to get this part here. And you'll notice I'm very carefully selecting which face I'm on. I'm really selecting the ring, but I'm selecting the outside ring, not the inside ring. And the reason is because I'm going to select the counterpart to that, which is this outside ring here. If I wanted to select this inside face right here, I would need to select the inside face of my part, because otherwise they wouldn't line up correctly. So I hit apply, and now I have those two faces constrained together. Next, we have our little post here. I'm going to use the mate. And I'm going to select this little bitty face here. The reason is the smaller the face, the harder it is to select. So if it's out in the open, it's really easy to select. Once I put it inside that part, it's near impossible to select. So I do that little bitty face first, and then I hit apply, and see what'll happen is I can select the inside face of my part real easily right here, and then notice it basically pretends like that part isn't even there once I select it, because it knows it can't be constrained to itself. So it allows me to go and I can pick a face over here, whatever, and I can pick that face that's on the inside of that part, and I can hit apply. So now I have one more constraint left to lock this to this, and I'll go back with the insert again. I'll say this hole to this hole, hit apply, and it's saying, hey, wait a minute, this can't be done because it conflicts with another one. So I'm going to say cancel this, and I notice, oh, okay, I've already constrained this part here to something else. Remember we were playing around earlier, and I must have left a constraint on. So I'll go to constraint again, change it back to insert here. So now it flops around there. Next, I have two more constraints. I have the angular constraint. What this allows me to do is I can select this face. I can select this face here. And I can say, hey, I just want these two faces. I don't have any more than that. I could go in and do an undirected angle. Directed angle says, okay, it's going in this direction. Undirected means that I could actually tell it which direction it's going to go. And it doesn't really matter on this one because it's going 90 degrees. But if I was going some odd angle, I could say, okay, this needs to be 45 from this. The explicit reference basically allows you to do a third reference angle on this. I'm not going to go into too much detail on here because this is a basic class and it gets complicated quickly. So I'm going to hit apply. I'm going to select this top face here and this top face here. And I'm going to say, okay, 45-degree angle, whatever I want it to be. It could be 0. It could be 15, whatever I may need it to be. And I hit apply. I have one last constraint on this first page, and it's the tangent constraint. What that's good for is, let's say this was actually rolling inside of here. So I could say this round face onto the side of this. In this case, I'm going to say to the end here, because there's not two flat faces to match together. So I can say this rounded face to this flat face. It would also allow it to basically slide up and down like a bearing or something like that if I wanted it to. And just like the flush and mate, inside, outside, how do you want those two faces to go together? We have two more that I'm not going to go into a whole lot of detail. This is very much a ball bearing or roller slides or something like this where you can actually have motion movements. Then you have transitional, which would be kind of a pipe sliding up and down a square tube or something like that. And then you get into constraint sets where it understands the different sets. Just due to time, we're not going to get into those. We just don't have the time to go through each individual one. So the big things to remember are, do you want mate, mate flush, insert, opposed or aligned, and then angle. Most of the time you're going to do directed angle. And don't forget to set your offset. If you do forget to set your offset, you can come down here and reset it. And then if you do a predict offset and orientation, make sure you turn it off when you get done. When you get done, you should have a part that looks something like this. Don't worry so much about what the angles are, getting them perfect, but you should have something that tells you that, hey, it can't rotate around. You'll notice there's still two free willies in here floating around. And what that is it's this ring here can wrap around this, which doesn't matter, doesn't even have a cutout in it. And then this bushing here can slide around this. Once again, doesn't really matter. Unlike sketch constraints, it doesn't hurt anything if you leave things unconstrained. In fact, the fewer constraints you apply, the better off you are. You don't want to over-constrain stuff. Think about it as in the real world. If you really have a bushing in there that's made to slide, basically meaning that it never locks, then let it never lock. If this was going to be rotational, I could delete this out so that this could rotate around. In the real world, you're not going to lock this down. You're going to let this thing go like this. And the same with my rotation on this. I locked this down to get started, but if I wanted to, I could delete that and free that up. So now I can move my parts around and be able to set my monitor on there and freely rotate it however I want. Most of the time I will, if it is a situation like this, I'll try to lock it down or Get it kind of close like that so that I don't have this thing going all willy-nilly on me. Play with it, see what you can do, and see if you can get something close to this. And we'll take a look at assemblies in another lesson.